So now what's going to happen is you're going to get a bunch of questions talking about whether or not functions are inverses of each other. So you might have something like this. It says, given f of x equal to 3x plus 2 and g of x equal to x minus 2 over 3, are these functions inverses of each other? All right. Super fun. So this is kind of like what we're going to be doing. So I'm going to write out these in my different colors because I just work better that way. So I've got 3x plus 2 and x minus 2 over 3. And the question is, are they inverses of each other? And the way to figure this out is to come over here. Remember we had up here, we said, if f of g of x is x and g of f of x is x, then they're going to be inverses of each other. So that's really what we're going to do. So our strategy is going to be to find f of g of x and then to find g of f of x. If both of these equal x, then the functions are inverses of each other. Does that make sense? Maybe. Maybe not. But if both of these equal x, then the functions are in fact inverses of each other. So that's what we're going to do with these here. So if this isn't, how do I say this? This is one of those things where you just have to do it enough until it finally makes sense. So you really just got to dive in, unfortunately. So let's just see what happens. The whole, and it actually really is cool when they do come out because you're like, wow, I did all that algebra and it turned out to be just as straightforward as x. That's pretty cool. So we did this on the last homework, so you should be kind of good at this. So g of x is x minus 2 over 3. All right, so f of g of x is f of x minus 2 over 3. So that means everywhere I see an x in the f function, I'm going to use the f function. And everywhere I see an x, instead of putting x, I'm going to put x minus 2 over 3. So actually, I want to see if I can fit all this on one line. So I'm going to shrink it down a little bit. I know you don't have that option, but you also have more paper than I do. Okay, so now if I look, the 3's cancel out. So I end up with x minus 2 plus 2, and that equals x. See that? That's a good sign. So we said I want both of these functions, both of these compositions of functions to equal x. If they do, that we have inverses of each other. So we've already started off well. So the next step is to find g of, and I'm going to come down one line. The next step is to find g of f of x. So we've got g of, and f of x is 3x plus 2. So I'm going to use the g function, except everywhere I see an x, I'm going to put 3x plus 2. So I start off with x minus 2. So instead of x minus 2, instead of blah minus 2, I'm going to do blah minus 2 over 3. And as I simplify, I can see the plus 2 and the minus 2 cancel out. So 3x over 3, and that equals x. So it's actually very, very elegant. So we can say, yes, these are inverses of each other because f of g of x is x and g of f of x is x. So they both work. So it's actually kind of cool. All right. There's a lot of material here. It's going to be super fun. All right. So let's try another one. Say, are these functions inverses of each other? Okay, so we've got f of x is 7x minus 4, and g of x is equal to x plus 7 over 4. So remember, we want to find f of g of x. We're going to find g of f of x. And we want these both to equal x. We want these both to equal x. So we've got f of g of x. G is x plus 7 over 4. So I'm going to stick this in here. So I've got my f. So I have 7x minus 4. So everywhere I see an x, I'm going to put a 4. I mean, everywhere I see an x, I'm going to put a x plus 7 over 4. 7 instead of x plus 7 over 4 minus 4. So I've got, I got something ugly. I've got 7 times x plus 7 over 4 minus, I need a common denominator, 16 over 4. Distribute my 7, I don't know, just trying stuff. But I'm starting to see that this is not looking pretty. So you're going to actually be able to see very quickly that that this is actually not going to work. And it wasn't supposed to, so I'm not actually that surprised. So that's as pretty as I can get. The whole point is that this is not equal to x, right? That is not equal to x. That did not come out pretty. Not pretty. And since that one didn't come out to x, it doesn't matter what the other one comes out to x. So no, these are not inverses. So these are not inverses of each other.